Today we're going to be discussing slope fields. It's our next topic here, and it's kind of neat. Um, so basically, what this is it's a way of solving those differential equations. Okay, like this, or like this. It's a way of solving them graphically. We already did a way algebraically, but sometimes we're not ready to solve it algebraically yet. So for that we use slope fields. Okay, and if you look at the definition, it's a graphical general solution to a differential equation. So basically, this is an example of wind, and we can imagine this as a slope field. And so what it's doing is our functions, our general solutions, it's going to be as if you imagine you are a feather, and you're going to be like floating through here. All right. So our slopes are kind of going to take us different ways, and we'll see that a little bit later. All right. So for our first problem, there's a whole bunch, blah, blah, blah. You can read that at any time you want, but here's an example. It'll be easiest to explain with that. So we're going to draw a slope field for this equation. All we do is if we plug in the point 0, 0, we're going to get a slope of 0. So we draw that. Okay, actually, in fact, anywhere that x is 0, we're going to get a slope of 0. So I'm going to fill that in. Okay, and the really important ones are 0, 1, -1, or infinity. Those you need to be spot on. Okay, so a flat line, 45-degree angle, 45-degree angle, straight up and down. All the other slopes need to be relative to those. All right, so now if we plug in a 1, we're going to get a slope of 1. So that's our 45-degree angle. So anywhere x is 1, wow, that's terrible. Okay, so you're just drawing these little lines. You want these little tangent lines to be big enough to see, but small enough so they don't interfere with the other points around them. All right, now if we plug in 2, we're going to get a slope of 4. So this just needs to be steeper than your other slope was. And just try your best to make it as accurate as possible. Okay, -1, if we plug that in, we again get a slope of 1. Okay, so that's my 45-degree angle. And plug in -2, and we get our slope of 4, which I'm going to try my best to keep it the same steepness as it is. It's not really the same, but it's close enough, okay? You can clearly see it's more than my slope of +1. So this slope field is a field of the solution curves. Okay, so for example, if my function went through here, my general solution, okay, here's one particular solution. Maybe it would go through this point. We would just say, kind of go with the flow here. It's follow the slopes. It's telling me what to do. All right, so it might look like that. And this is a slope of 0, and then it kind of slants down. Okay, so that could be one solution curve, which kind of looks like an x cubed. All right, for some value. If I pick something else, maybe I want to pick this point. All right, then I would kind of follow it this way, and it gets steeper. All right, and it would look like that, and that would be like another x cubed. All right, plus some other constant. So, and we could, for this one, because it's a simple equation here, we know that the antiderivative, and remember, we write that as as a separable differential equation. If we integrate this, we get y equals 1/3 x cubed plus c. So that is our general solution, and this is the family of solution curves graphically. All right, so and all of these are exactly what I was just talking about. So this is actually a bigger solution curve made with Mathematica. And later I'll show you how to do them on your calculator so you could get this great screen. All right, so I'll talk about that in class if you'd like to. All right, so then example 2, sketch the graph of the solution of the initial value problem. So we have our differential equation and we have an initial condition. Now for this, on an AP exam, you would never be expected to graph this many points. That's way too many. You might be looking more at like 9 points, maybe 12. All right, but first, let's look. So when x and y are opposites, that slope is going to be 0. So we have negative 1, 1, negative 2, 2, 0, 0, 1, negative 1, 2, negative 2. All of those are 0. So I plotted those first. I thought it would be easier. All right. So then along that, if I go to the point negative 1, 2, if I plug that in, I'm going to get positive 1. If I plug in 0, 1, I'm going to get positive 1. If I plug in 1, 0, positive 1. So all of these along this are positive 1. All right, and then you kind of just go from there. 0, 2, if I plug that in, I'm going to get a slope of 2, so I just got to make it a little bit steeper. Okay, 1, 1, again, that's 2, and 2, and 2, and then you'll see that it gets steeper. You can follow along. Wow, that's way too steep there. Okay, so I'm going to try to make it a little bit steeper, a little bit steeper, a little bit steeper. Okay, you could get these values yourself. Now as you go, let's say negative 1, 0, that's a slope of negative 1. All right, why can't it draw there? Okay, that's exactly what I want to do. Great. Negative 1, or negative 2, 1. Again, it's a slope of negative 1, negative 1, all the way down this line. Okay, and they get a little bit steeper. I'm just going to fill some of these in. You check the actual numbers. Steeper, steeper, steeper. Great. Okay. So now sketch a solution of the initial value problem going through the point 0, 1. So there's our point. You want to clearly indicate that. And you kind of just go with the flow here. Follow the slope lines. Okay, it's saying go down, then it flattens out, and then it kind of shoots up, follows along that line. So that would be the example at the point 0, 1, the solution. Now it could look a little different, right? Let's try 1, 1, negative 2. If I start there, okay, this side, it looks like it would just kind of keep going down, and then we'd follow that slope, and this one actually looks like a straight line. Let's see, let's try another one, maybe like something over here in this third quadrant. Negative 2, negative 1. All right, negative 2, negative 1. So it looks like this is kind of steep, and maybe I'd kind of be following that and that. Okay, there you go, another graph. So this function has a lot of different kinds of solutions. If you try to separate the variables, you're going to see that you're unable to. So that's a problem we can't do algebraically unless you take, you know, ordinary differential equations in college. Fun class, fun class. All right. So this is a little more realistic of what you'd be expected. 9 different points. All right. So plug these in. You plug in 0, 0, you get negative 1. If you plug in 1, 1, we're going to get a slope of, 0, 1. Let's talk about that one. That'll be easier. Okay, how about 1, 0? Same thing. 0, negative 1. And negative 1, 0. Those are easy. If you plug in 1, 1, you're going to get a slope of 1. 1, 1, 1. Great. All right, then sketch the solution curve that passes through the origin. Now, this isn't really a lot of information to kind of sketch this curve, so we'll just try our best. All right, so it goes down to a certain point. It's 0, and then it kind of goes up. So maybe it's something like this, and 0, and it goes down. So there we go, something like that. Here's a bigger graph, okay, from negative 3 to 3 with lots of little slope curves. But see how in the middle it's kind of all different? Okay, that's because of the changes in the different solution curves. So this would be one example, okay, passing through those points. This would be another example of a function that could be a solution to this problem. Okay, and yet another one. So they all have this general pattern, but they can vary very much depending on what specific points they're passing through. All right, now another way to do this would be to go backwards. If you're given the solution or slope field, you want to find the equation of that general or particular function. So let's see, start anywhere you want and try to follow those curves. Now what does that look like? Okay, it's either sine or cosine, right? But it looks like that middle point is crossing through there, so I would say that is choice F. Alright, on the other hand, this graph here, depending on where I start steep, flatten out, get higher, okay? Now, notice these slope lines that looks like infinity or really steep, alright? So it could be tangent, but I don't see that on there, so the only other choice we have for ours is letter D. Alright, another one, this is one that I'd like you to do for your whisk. Okay, find the example 5, write the letter choice and the function if you want for this one. See if you can kind of sketch out a graph and which one doesn't match. And then the last thing, the last one that I'd like to do right now would be example 6. So there's a couple of ways of doing this. You can look at the functions and decide on the graphs, or look at the graphs and decide on the functions. Alright, so one thing I see right away is I kind of see this shape or something similar to that. So to me, that any kind of, well, I kind of messed that up. Any kind of straightened curvy function like that would have to be something like sine. Let's see, what's another one that would be good? Well, look, I noticed that this right here, there's a flat line across the 2. So whenever y is 2, my slope is 0. So the only one that would kind of go along with that would be letter number 3. Okay, the next one, let's see, where would I go next? Well, this one's kind of neat, right? If I draw this, it could be something like this. It could be something like that. The only function I see here, it looks like e to the x. Alright, what color have I used? There we go. This one here. So, again, I notice here, when x equals 0, the slope is 0. When x equals 1, the slope is 1. When x equals 3, the slope is 3. So it's only depending upon the x. And if I graph it, it would kind of look, oh, okay. It would kind of look something like that. So it looks like this is B. Alright, and let's see, 2 left. Let's see, when I see the x and the y's, when they are opposite, or when they're the same, like 1, 1, 2, 2, 3, 3, I end up getting 0. Okay, so for this one, if I had 1 over 1, that's not 0, but 1 minus 1 is 0, so that must be choice E. And our last one, x over y. Well, first, y cannot be 0. Right, because if we have x over 0, it's undefined. So y equals 0, we have these undefined slope lines, okay? They're like straight up and down along that axis. I also see when x and y are the same, it looks like a slope of 1 along that line, -1 along that line. Okay, so these could be different kinds of curves. It could be something like this, something like that. And if you recognize that, maybe from Algebra 2, it looks like a hyperbola. So if you would like, there are a couple other ones to match. I'd like you to at least look at example 7, see if you can figure it out, and we'll talk about it in class.